So here are the solutions, and undoubtedly, if anybody had a problem with part A, it came from the fact that we have x divided by 3, something that we haven't really talked about, but kind of we have talked about it. Because after all, having minus x over 3 is the same thing as having minus 1/3 of x. You should have strong enough algebra skills to be able to understand that fact, to do the fraction algebra on these terms and realize that that's the same thing, so that this is really a constant multiple. And so our constant multiple rule applies, which says that you just forget about the constant multiple and compute the derivative of the non-constant part, and at the end you multiply them together. Well, the derivative of x is just equal to 1. So this is negative 1/3 times 1, which is just negative 1/3. So hopefully the rest of this answer makes perfectly good sense, right? This has derivative 2x, this has derivative 0, so I don't even write it. Okay, moving on to the next. You should really just think of this as a constant. So if you think of this as just some constant number, like 2 or 1 or whatever, then the derivative is just equal to 0. We've seen that a couple times now, that the derivative of a constant is 0. But if you want to phrase it in terms of the power rule, then you could say, well, this is the same thing as square root 2 times 1, and 1 is the same thing as x to the 0. And now we apply the power rule. And so you have 0 times x to the negative 1. But hey, this just has 0 as a multiple, right? So as soon as 0 gets into the mix as a multiple, the whole thing just turns into 0, right? 0 times anything is 0. So that's the answer. Here, we could do a similar trick, regard x as x to the 1, and then apply the power rule, and x to the 0 is just equal to 1. So this is pi times 1 times 1. It's just equal to pi. Here, we use a similar trick to the one in part A, which is to regard 5 cosine x over 2 as really just 5 over 2 times cosine, and then take the derivative of cosine, which is negative sine, and that explains the negative to the left and the sine to the right. Then over here, it's just a fairly obvious power rule. Drop the 3 down, combine it with the 3 that's already sitting outside, you get 27. Sorry, no, you get 9. And then x squared is left over. And here, okay, tangent times cosine. Well, tangent is just sine over cosine. If you then multiply by cosine, it's just equal to sine. And therefore, we have, we're taking the derivative of sine, basically. And so the derivative of sine is cosine. So that's the answer. Notice that you do not know enough, if you're following the videos, you don't know enough to figure out what the derivative of tangent on its own is yet. We're getting there eventually, but right now you can't figure it out. But I set things up so that if you just realize the appropriate trig identity and simplified, then you could get the derivative. Here, similar thing happens. You cannot take the derivative of a fraction. You don't know how to do that yet. I promise you it is not what you would instinctively do if you have an instinct about it. So instead what you have to do is factor the numerator, and it factors into x minus 1, x minus 1. You cancel factors, and so you only have an x minus 1 left in the numerator. So we're taking the derivative of x minus 1. What is that derivative? Well, the derivative of x is equal to 1. The derivative of negative 1 is equal to 0 because it's a constant. And so you have that the end result is 1.